Hi guys, welcome. I am a little bit under the weather right now. Running a fever. I'm going to try to get through this as quickly as I can. This is obviously your first chapter 13 video, and I want to make this brief. There are not going to be any associated notes with this, mainly because if you look down in the bottom right corner, you can check out the time that I'm making this video. So let's start with a recap of surveys, okay? What a survey does, what the whole goal of a survey is. So, oh yeah, and I should note that, wait, no, I do have a fever. I think I told you that there are no notes associated with this video. So I would just write this down. I want to keep this to, we'll see. My goal is for under 20 minutes. I think we can do that. Survey is a snapshot of a feature which we have been calling, the feature of interest here is the parameter of interest of a group of people. Let me get my notes handy here. Group of people or things which constitutes our population using a subgroup, that is a smaller group within the population, which we call the sample. Oh, the M is a little bit messed up. To estimate the parameter of interest. Okay? So the key word there, I think, is estimate. Why? Because as you guys are going to see as you conduct your survey, project surveys, and you get those done sometime after Thanksgiving break, I'll give you a heads up on when exactly the due date is. Hopefully next time I see you, that'll be what I'm shooting for. It's been a busy week. I don't know if that'll happen or not, but I'll try my best. At the bare minimum, it'll be, let's see, boom, boom. Well, it really should be next time I see you. I want it to be before Thanksgiving. Okay, so a survey is a snapshot. The example that I used last time we talked about surveys was that of sort of the matronly chef who is, as long as she's doing a good job of sampling or surveying her soup, and she cares about maybe the saltiness within the soup, she's doing that at a single point in time. Hence why I called that a snapshot. Okay, so if, for instance, she takes a sample of the soup, of the saltiness of the soup. Let's say she mixes it well. She uses a large enough ladle, big spoon, that is to say, to sample what the soup contents are like. If the soup continues to boil and the water is evaporating from the soup contents, obviously the saltiness is going to rise. So the data, the usefulness rather of the data, changes with time. Okay, so in that sense, a survey is absolutely a snapshot. It's just what does the population look at a given point in time. Okay, so an example here for contrast purposes. I don't think that you will be confused by this one bit. Example would be use an SRS, a simple random sample, that is common abbreviation, which you may use at both in this class and on the AP exam, to sample 50 students at random from YHS student body, okay, to estimate average height. Okay, we're going to focus on the heights of the students here at Yorktown as we look at observational studies and experiments and contrast those with surveys. So let's say I don't want to look at just that snapshot in time. Let's say instead of caring to learn about what a group of people looks like right now or in the future when I would conduct my survey, I instead care to look at excuse me. I instead care to look at how introducing some new element to the environment for the people here at Yorktown changes their heights. That's confusingly worded. Let's come up with a more practical example. Let's say I want to see what the influence of drinking milk has for students' heights here at Yorktown. Okay, that we cannot do using a survey because, again, being a snapshot, we won't know how things change with time trying to use a survey. Instead, one option, and it's not the better of the two, but it's common, hence we're going to cover it. They are used in higher academia. I'm sure that at some point when you're going even through your bachelor's degree, you will look at case studies, which is a type of observational study, okay, which tries to see the influence of that factor, that element that's either being introduced or already introduced into the population to determine its effects upon that population. So the definition of an observational study, at least in my terms, the book may give something slightly different. It's really just going to be more or less synonymous definitions here. Looks at how one factor, which is the group characteristic whose influence, well, that's characteristic, whose group characteristic, whose influence we care to observe, has, let's see, looks at how one factor has influenced 2+ groups of people or things. People/things in a given way. So let's come up with an example here. Let's say that, suppose I care to learn about how drinking milk, has influenced the heights of students here at Yorktown High School. Suppose that 2, you have recorded your heights as of yesterday and as of 4 years ago. Okay, so is that a little bit of a hypothetical stretch? Yeah, sure, but I mean, certainly you can imagine that being the case. Let's say, even though this is weird, you've got in your daily planner your height as of yesterday and your height as of 4 years ago. If I go to the cafeteria during a lunch, that could be either literally a lunch or just any given lunch at all, and ask students, okay, so my questions are the following. I ask them, A, if they drink milk. I ask them, B, what their height was 4 years ago. Let's just say height 4 years ago. Height 4 years ago. And I also ask them, C, wait, where did I write that? What your height was yesterday. What your height was yesterday. Okay, so I can organize the information I get from these students in the cafeteria. We've not selected a size of participants in this observational study. Most observational studies try to shoot for some number in advance. But for now, I'm just trying to teach the basics of observational studies. So we'll not worry about the participation size at this point. I can organize the information that I get from people into 2 groups of people and compare the influence of milk between the groups. Okay, so just looking at the non-milk drinkers, comparing them to the milk drinkers with regard to their heights. So 4 years ago, maybe the non-milk drinkers averaged 5'1". 5'1". Maybe now their height is 5'8". Okay, and the milk drinkers, on the other hand, perhaps 4 years ago, had an average height of 5'2", so comparable to the non-milk drinkers, and then now their height is a larger 5'11". Okay, so obviously it's very tempting to go ahead and say, well, okay, the 2 different groups, the 2 different disparate groups, started off relatively comparable. Yeah, the milk drinkers were an inch taller than the non-milk drinkers, but by the time these 4 years have elapsed, assuming the data was taken accurately, precisely, then you've got milk drinkers shooting ahead an additional 2 inches from where they started. So it certainly appears that milk drinking has influenced their height in a beneficial way, if it's a benefit to be taller. Okay, so what are some problems in making that analysis? Well, the following I can think of. I'm sure there's more. Sure, there's more out there. First, milk is expensive. Okay, think about the groups of people, and maybe this doesn't cross your mind, but it has since I've been in college. Think about the groups of people who have access to milk. Ever since the swimming days, I've been a huge fan of milk myself. And organic milk, if you go to Meijer, you're looking at dropping $7 for a single gallon. That is a lot of money for someone who's living paycheck to paycheck on a minimum wage. That is more than an hour's worth of work post-taxes deducted from a paycheck. That's expensive. So one possibility here is that the group of milk drinkers might simply be from a higher socioeconomic status, which has access to this, yes, nutritious, but relatively expensive food. Okay, there's one problem. These groups may naturally be different in that way. Okay, secondly, oh man, I'm dragging. Oh yeah, parental influence. What do I mean by that? I mean that perhaps the milk drinkers have naturally taller parents on average than the non-milk drinkers. That's something that if all I've done is gone to the cafeteria and I have interviewed people to determine their heights before and after, I can't know that. That's something that, again, could naturally be different between these two groups. So it could, again, influence the results. These two things so far have diluted my ability they've weakened my ability to say that milk has this cause and effect relationship upon heights. Okay, so third thing here that I want to come up with, and this is important even though it's not specific, is that perhaps milk drinkers differ in ways we can't predict. What I've observed from teaching this course for a couple of years is that it is kind of fun. People enjoy the brainstorming, coming up with, oh, look at this observational study. They made this conclusion, in this case, that drinking milk excuse me, positively influenced the height of students here at Yorktown. Well, students like to come up with all the ways in which that conclusion is just simply not valid, given things that may not have been taken into account in an observational study. So, what is your solution? Well, something that you've done before. An experiment. Okay? I wonder if all the experiments that you've done have used randomization here. And no, I'm sure that's not been the case. Interesting. Well, a statistical experiment may look slightly different than how you would run a high school science experiment. I hadn't really thought about that before. I need to talk to science teachers about how they like to run their experiments. I'm curious now. All right, so it too, definitionally, looks at how one factor, which is that characteristic in the environment that you care to observe its influence, has, oh, I guess I preempted myself, has influenced 2+ different groups of people or things in a given way. Okay, so really, its aim is the same, at least for the intents and purposes of this class, as an observational study. People or things in a given way. Okay, all right. So let's come up with an example. Suppose if the experiment has the same aims as the observational study, let's go ahead and use a similar example. Okay? Suppose I care to learn about how milk drinking will influence the heights of students here at Yorktown High School. I can take a group of volunteers. Notice this is different than surveys in that I've not randomly selected my volunteers, and that's okay. I can have volunteers elect to be in the experiment and record all of their heights before the experiment begins. Next, I can, and here's where the randomization comes in, I can randomly assign half of the students to drink milk daily and half of the students to not drink milk daily. Okay? That randomness, just as with surveys, is your best counter to bias that is either known or unknown. Okay? And then once let's say after 4 years elapse, which that's a really long experiment, I can then record their heights to determine the effects of drinking milk. Okay, so what are the benefits? I guess I really don't need to, I'm not going to write out what the example was. You can record that yourself if you care to. The benefits include random assignment, it may not ensure, it doesn't ensure that both of the groups that I'm trying to contrast here will be, they will look identical with respect to all characteristics. What do I mean by that? That doesn't automatically ensure that, again, if I care to, let's say I have 50 volunteers and I randomly assign them into each of these two groups, that doesn't mean in the first group of 25 that I will have 2 people at Riley Neal's height. Doesn't mean in the first group, or excuse me, in the first and the second group I will have 2 people of Riley Neal's height. It doesn't mean that you'd have 2 people at my height. But it means that those ways in which people differ with regard to their diet, parentally, or their daily routine, that'll be mixed up in such a way that the 2 groups will probably be mixed up enough that we can compare them. Because we shouldn't have, as long as the assignment has been random, all the higher SES people with access to a better diet in the milk drinking group, because they could have been randomly assigned in the non-milking group as well. Okay, so the benefits by random assignment to each of the 2 groups, we should, okay, again, it doesn't ensure, but it increases the likelihood, have a balance of people in each group. Okay. With regard to the parents' heights and normal diet, additionally, any other factors that we can't account for should also be randomly distributed between the 2 groups. Okay, what I want to do next, and this is the last thing we're going to do here. Let me check the time. 17. Okay, so we're going to overshoot 20 by just a little bit. Let's come up with, and we'll use this a lot, let's draw a diagram of the experiment, which will help us to both understand and communicate the experimental design we have in this case. So we have, in all, we said 50 participants, okay? And we said that once you've got your 50 participants, which do not have to be selected at random from the Yorktown High School, but they are randomly assigned to one of the 2 different treatment groups, milk drinking or non-milk drinking, okay? Then we do exactly what we just said. We put them in their groups randomly. Random assignment. Okay, in caps, just to signify the importance here, into milk drinkers and non-milk drinkers. Okay, so we're just identifying the groups. I don't think this is a hard diagram to understand. Then, for each of those 2 different groups, we treat them, okay? We tell them, well, milk drinkers, you have treatment 1, which is to drink milk daily. All right, and then for treatment 2, for the non-milk drinkers, that's pretty self-explanatory, we will not drink milk daily, okay? And then once you've got the results 4 years down the line, last but not least, you take the information you've got from these 2 different groups and you compare the heights after 4 years. Compare heights after 4 years. Okay. All right, so let me just real quick talk about the elements of this diagram, experimental diagram that you're going to see virtually every time you encounter an experimental diagram. First chunk, and I'll do this in red, is always going to be, oh, let's just make this a solid line across. First chunk will always be who your participants are. Okay, the next chunk is your random assignment, which, notice in the diagram, that's not specified as to how we're randomly assigning. If you are describing how you would conduct an experiment, that becomes important to do. In the experimental diagram, it will not be demonstrated in a description of the experiment which would accompany this diagram. You're going to say how you'd randomize. So for instance, a simple example, let's say I've got the 50 people, I assign each a number from 1 to 50. I do randint from 1 to 50, 25 times, ignoring repeats, to assign people to the milk drinkers group, and everyone who didn't get randomly selected would go to the milk drinkers group, would go to the non-milk drinkers group. Okay, so that random assignment process is not elaborated in the diagram. That it needs to be done in a description of how you conduct an experiment, and we'll talk more about that later. Okay, so next you've got your groupings. Finally, you've got your treatments. Specifying how the factor differs between groups. Okay, so the factor in this case, the characteristic that differs between the groups was the daily intake of milk. And then last but not least, you've got your analysis in the final phase of your experimental diagram. Okay, so there is a contrast of starting with surveys, what we've seen in Chapter 12, moving to observational studies. And I guess I should mention this now. Observational studies are conducted because they're easy. Frequently, people might already be organized into two groups in a convenient way, but as I hope you noticed, I guess I didn't really talk about this a whole lot, observational studies, because they don't randomize, it's really hard to generalize any results you get to bigger groups of people. So for instance, think back to if I've got 50 people who I've interviewed in the cafeteria, and I've grouped them into non-milk drinkers and milk drinkers based upon their diets for the past 4 years. Because those two groups differ in ways that I can or cannot predict, I can't generalize the results to the Yorktown High School student body at large, but because the treatment, that is to say, people drinking milk or not drinking milk, they did themselves. So it eliminates some of the work for me in looking at the effects that milk has based upon heights of these groups of people. On the other hand, the experiment, that's sort of the golden cow. It is, it's the best way that we have to look at how a factor, or we'll get to multifactorial experiments, which is to just say a couple of environmental influences can change something that we're trying to observe in a group. So for instance, I could look at the effect that drinking milk daily, or maybe on top of that, regular exercise too, as an experiment. We'll get again to that later. So there you go. Hopefully you appreciate the brevity here.